Hello, ladies and gentlemen, and welcome to Physical Science, the section about the periodic chart, which is found in chapter 17 of your books. We are going to be talking about development of the periodic chart, basically how it came to be, starting from long ago. This is basically related to the beginnings of chemistry. Originally, chemistry was part of what is known as alchemy, and that was back when people were just kind of trying to throw things together and see what you ended up. You can see over here on the right, the four basic elements were fire, air, water, and earth. And you'll notice all of the strange symbols that were used by the alchemists. Primarily that was so that their recipes were secret if somebody found their journal, in case they happened to discover gold or something else that would be highly money-making. So that is the primary motive for alchemy, was to find things that were useful or potentially money-making. But originally you just had those four ideas of fire, air, water, and earth. And you hear about that sometimes still with stories and things. Okay, that persisted long until the 1700s. And you had Marie and Antoine Lavoisier. They're the ones that really defined chemistry as we now see it. They started using specific measurements and making things very clear-cut and scientific, instead of having, just kind of add this to this and see what happens. They started writing down their experiments, and she was just as much a part of it as he was. They're often considered the mother and father of chemistry. And they started making chemistry pretty significant. However, their career was cut short by the French Revolution. Pun partly intended. So history continued. In England, in 1803, John Dalton, which should sound familiar for his atomic theory billiard ball, was also studying chemistry, and he started to create these symbols for the different elements. Now, some of them you might notice are not actually elements. Things like lime is actually a combination of calcium and carbon and oxygen, but they were having trouble separating things out and figuring what were elements and what were molecules or compounds. But his idea did not really catch on, because if you haven't noticed, although his symbols are very artistic, they are also very complicated and hard to remember. Fortunately for us, at about the same time period, Jacob Berzelius, who was also a teacher, came up with the idea of simply using the first two letters of an element's Latin name. Now, some of these have been changed over time due to the name of an element changing. For example, Fe is iron. That, it's not IR, it's Fe. That's because the name for iron used to be ferrous, and there's a number of other elements that were identified this way. When he came up with his system, there were about 50 different known elements. Now we're up to 118, so a lot's happened since. Johann Dobereiner started realizing there were patterns to the different elements, and realizing that their weight, or their atomic mass, as we now refer to it, started having something related to a pattern as to how these different elements kind of started fitting together and creating a pattern. So He called his sections triads because he noticed there was this thing about these three things. If you see over on the left, you have lithium, sodium, and potassium. He noticed there were similarities between them. And even today, if you look at a periodic chart, you will see that lithium, sodium, and potassium are grouped together. And he gets the idea of these threes with the triads. John Newlands noticed that these elements actually, instead of being in threes, actually were in patterns of eights. And that's where he took his love of music and realized that music has one octave is 8. So he started arranging the elements in sections of eighths, and he called them octaves because of his love of music besides chemistry. And that is similar to what we use today, although you'll notice there are changes and modifications over time as more things were learned. The one that made the biggest change was Dmitri Mendeleev. You'll notice he still has the eights, just like John Newland specified, but you see all these blanks throughout the chart where there's just kind of these spaces. He is the one that realized that not only did they follow a pattern, but that we didn't have all the information. So he was unique in that he didn't just try to organize the elements, but he realized there were elements that were unknown and that they would fit into those spots. It required a lot of foresight on his part. He still had it divided by 8, but just the insight to realize we didn't know what those elements were yet was a big contribution by Mendeleev, because that allowed for things to have a set pattern, so when they were discovered, they could be fit into position. Now, up to this time, all of the elements had been organized by their atomic mass, which remember is the number of protons and the number of neutrons together. In time, a young man by the name of Henry Moseley realized that that didn't work very well. There were times when things didn't follow that pattern, where the atomic mass put things in the wrong order of where things really should be based on how they acted. And Henry Moseley, in his insight, pretty young in life, you can see he was very young, realized that better than arranging by atomic mass, the number of protons and neutrons, that the periodic chart should be arranged by the atomic number, which is just the number of protons. Because protons and neutrons sometimes aren't the same, so they varied from place to place. He actually created the format of how the periodic chart is today. He did leave some blanks, which you can see down by radon and over here by tellurium and so on. So he still realized, just like Mendeleev, that there needed to be there were some gaps still. But the sad part of Henry Moseley is World War I came along, and even though he was highly gifted and the royalty did not want him to go to war, he felt such patriotism for World War I